In this little video, we're going to start not here. We're actually going to start up here. So this is under polynomials, working with them and simplifying expressions, that sort of mess. There is several ways of doing this. I prefer to distribute whenever I can. That way I can move stuff around at will. So here is going to be a demonstration of the distributive property and the commutative property, as well as to redistribute in order to combine like terms. Now, I highly recommend, until you get very, very used to it, that anytime a number occurs out in front of a set of parentheses, that you distribute that along with the sign of the number. So in the second grouping here, you'll notice that we didn't have a number explicitly written in front of the parentheses. So we assume it to be 1. That's the general assumption for mathematicians, is if you don't see anything in front of it, it's a 1. And for the exponents, if you don't see anything, it's a 1. Later on, it might be a 0. But it's still an identity nonetheless. All right, so we're going to go ahead and we're going to distribute all of this stuff. Now the negative 4, because it's separated from the 8x plus 2 by a minus sign, the negative 4 only applies to this first grouping. So negative 4 times x is simply negative 4x to signify the multiplication. Yes, and my dog is right here doing support of me. Negative 4, and now you can, I can make the argument that it truly is a negative 6. However, if you just kind of get used to the sign in front of the number as being the sign of the number, it's a lot easier to work with. So a negative 4 times a negative 6 is a positive 24. Then, negative 1. Notice I'm not putting a sign down. As it turns out, whatever the sign of the number is can also be thought of as the operation. And that has to do with the invertibility of the plus and the minus, whether it's adding a negative or subtracting a positive. Either way. So, negative 1 times 8x is just a negative 8x. Negative 1 times a positive 2 is a negative 2. Notice I'm using the sign as the operator. And then, of course, the rest of this stuff just comes down, minus 3x.
Yes, I see that you have your stick. Thank you.
So now I can pick up and move all of the common terms next to one another. This is the commutative property of addition. So this is negative 4x minus 8x minus 3x. And then I can write the rest of it just as normal, plus 24 minus 2. Then I just combine like terms. This is like saying negative 4 minus 8 minus 3, and then take all that stuff and multiply by x. Most people just skip over that part, although it's not technically correct to do so. Negative 4 minus 8 is negative 12, minus 3 is negative 15x. Positive 24 minus 2 is a positive 22. And so this whole thing shrinks down to that. And the reason why this skill set might be needed is that you're most likely to have to work with something like this in a formula, and they're not going to substitute in nicely. So anytime you're having to do this, it's a little bit easier to simplify before you move on. That would be the reason why. All right, let's try another one, because why not? I wrote it down, so we might as well try it. Again, looks a little bit complicated, that sort of thing. As always, order of operations says you want to work with the parentheses. Well, the stuff inside the parentheses can't be combined. They're not like terms. So the x's and the 10s, the 8s and the x's and the 2s and the 2x's and the 1, those can't be combined because they're unlike terms. So we look then outside of them. But at the same time, we don't want to go completely outside. That would be a hot mess. We are going to concentrate just in here, and anytime we see an operation next to the parenthesis, we're going to assume that it's a 1 as our number. And then we're going to wash, rinse, repeat exactly what we did before. We're just going to distribute the stuff inside, then we're going to kind of cram it together, and then we're going to multiply by the negative 3. So the negative 3 is on the same level of this plus 2x minus 1. So let's start in here. First of all, I'll bring down my negative 3 and that. This is going to be negative x. And then I start my distribution. Positive 1 times a positive 10 is a positive 10. Positive 1 times negative 3 is a negative 3x. Then I move on to this one here. Negative 1 times 8 is a negative 8. Negative 1 times negative 3 is a positive 3x. That finishes out what's inside the brackets. Everything else comes down. As you get used to this, you might find yourself doing whatever work you need to kind of off on the side or maybe even in your head, but then just writing everything down to include the answer. So, moving along here, I'm going to go ahead and combine like terms from here. This uses the same method as above, only this time I'm not going to explicitly use the commutative property. We're just going to understand that it happens, and it allows us to group all of our like terms together. So I've got a negative x here, a negative 3x here, and a positive 3x here. Well, a positive 3 plus a negative 3 is going to equal 0, so those in effect eliminate. They do not cancel, you cancel factors. These are terms, you eliminate terms. And the only thing we have left is a negative x. Now, normally what I would do is I would just go ahead and I would cross that out lightly, and that tells me that I'm done using it. The others were crossed out because in a sense I've used them and made 0, and 0 minus 1 is just negative 1. And then on the next piece here, we have this positive 10. We have a negative 8. So 10 minus 8 is a positive 2. And everything else comes down. Now, in this next step, I can go ahead and I can manipulate the negative 3 in through here, as well as the positive 1 that's here for the 2x minus 1. So negative 3 times, and so I'm going to distribute throughout. Negative 3 times negative 1 is a positive 3x. Negative 3 times a positive 2 is a negative 6. Positive 1 times 2x is positive 2x. Positive 1 times negative 1 is a negative 1. And again, I'm just going to go through here, and I'm going to go ahead and combine like terms. So I take my positive 3x, my positive 2x. They combine to be 5x. And those are done. Negative 6 minus 1 is a negative 7. And that's the answer. So a lot of this stuff is just, it's the same thing over and over and over again. Much like any complicated machine is made up of the 7 simple machines over and over and over and over again, so is math. A lot of the more complicated problems in math that you'll be seeing is nothing more than just an iteration of simple concepts over and over and over. That's really it. So, well, I hope this helped you. Take care.